All right, guys. This is 4.4, matrices, the basic operations for matrices. What is a matrix, you ask? It is a number crunching machine that does everything from basic math to heavy advanced math. Matrices run the world. I will just tell you that, okay? Once you get into more advanced math, you'll realize that they use matrices to help solve problems. So yes, so matrices are crazy. And we are only going to do the basic operations. All right, so we'll start with addition and subtraction. Two matrices are equal if they are the same size and each of the corresponding elements are equal. Add those. So the first matrix is A, B, C, D, E, F, and we're saying it's equivalent to the second matrix, U, V, W, X, Y, Z, where element A is equal to U, element B is equal to V, C to W, D to X, D to Y, F to Z. Okay, so to add or subtract two matrices, they must be the same size. All right, so for example, 1 there. You see matrix 1 is -2, 5, 7, 4, -3, 6. And matrix 2 is 4, 3, 8, 9, -4, 2. So we see that these matrices are the same size. And what I mean by the same size is to state the dimensions of a matrix, it's always rows times columns. So matrix 1 would have 2 rows and 3 columns. Matrix 2 has 2 rows, 3 columns. Since they are the same size, you can add these matrices together. So rows, columns. Okay, and you see the corresponding operation. You get -2 plus 4, so the first element in the first matrix plus the first element in the second matrix. -2 plus 4, 5 plus 3, 7 plus 8, 4 plus 9, -3 plus -4, and 6 plus 2. Gives us the final matrix, which is also 2 by 3, of 2, 8, 15, 13, -7, and 8. So we also will end up with the same size matrix when you add and subtract them. Okay, let's try it out on our own. Okay, so here we have our two matrices. Yes, they look the same size, but let's also put the dimensions. Matrix 1 has 3 rows and 2 columns. Matrix 2, same thing, 3 rows, 2 columns. Okay, now let's put it together. You'll get, since they are the same size, we can add them. So we'll get 4 plus 8. So first element in the first matrix plus the first element in the second matrix. And then 3 plus -2. And I'll put this here to separate the columns. All right, and then do it again. -5 plus 2, and then 0 plus 13. One more time. 9 plus 3, and -1 plus -7. Okay. Add them up. And we'll get 12, -3, 12, 1, 13, -8. And again, we end up with a matrix that still has 3 rows, 2 columns. That's perfect. Okay, awesome. Okay, so that's adding 2 matrices. Down below are some properties of addition that can be applied to matrices. So the commutative property of addition says A plus B equals B plus A. So that means that, let's say, looking at the above, the first one was matrix A, and the second one was matrix B. Well, all the commutative property says is that it doesn't matter if it's A plus B or B plus A, because no matter what, we'll get the same result. That's all the commutative property says. Okay. Now, the associative property of addition says A plus parentheses B plus C is the same as parentheses A plus B plus C. So let's say you were adding 3 matrices together, right? It wouldn't matter the order of which you added them, because no matter what, you would get the same result. So you could do B plus C first and then add A, or you can do A and B first and then add C. That's all the associative property says. And these properties can be applied to matrices, because in a way, matrices are also purely algebraic. All right. So a matrix whose elements are only zeros is called a zero matrix. So you see, those are examples of zero matrices, where every element is a 0. All right. The negative of a matrix, A is denoted by negative A, is a matrix with elements that are the opposite signs of the elements in A. So if matrix A is A, B, C, D, then negative matrix A is negative A, negative B, negative C, negative D. And A plus negative A, so matrix A plus negative A would equal 0. Okay. Subtracting 2 matrices, of course, to subtract 2 matrices, they must be the same size. So again, I'll just put the size here. The first matrix is 2 rows by 3 columns. The second one is 2 rows by 3 columns. And since they're the same size, subtract the elements. So just like you see here, 8 minus 5, right there. First element in matrix 1 minus the first element in matrix 2. So on and so on until we get to the final matrix, which is also a 2 by 3. Okay. Let's try it out. First, let's put the dimensions. And our first matrix is 3 rows by 3 columns. 3 rows by 3 columns. Our second matrix is also 3 rows by 3 columns. Set it up, and let's get started. First element in matrix 1 minus the second element in matrix 2. So 9 minus 3, and I'll work my way down. Then I'll do 0 minus 5, and then I'll do negative 2 minus 8. Let me separate the columns just to be neat, and let's do it again. Now I'll do 3.5 minus 1. And then 6 minus negative 8. And then 7 minus 0. separate that column. Again, -1 minus 3. -1 minus 3. And then 6 minus 4.2. And then 8.4 minus 9. Close it off. Okay, and then just subtract them. And we should get 6, -5, -10, 2.5, 14, 7. Oop, did I miss the minus? Yep, -1 minus -3. So that'll be 2. That'll be 1.8. And that'll be -0.6. And there you go. That is adding and subtracting matrices. Now you're probably wondering, can I make your life easier? And the answer is yes. Watch. This is the beauty of calculators, right? Okay. So let me share my screen. And let's see. Okay, so watch this. On the graphing calculator, we're going to go to second matrix right here. All right. Then we're going to go over to edit. And I'm going to say matrix A. And I'm going to use the last example. The last one was a 3 by 3. So this one wants the dimensions. 3 by 3. All right. Now let's put in our values. 9, 3.5, -1. So it works from left to right. So it's going row by row. 0, 6, 6, -2, 7, 8.4. All right. Now we're going to say second quit, and then back to second matrix. And now all that information is already saved in matrix A. So now let's go make matrix B, which is also 3 by 3. And then we'll have 3, 1, -3, 5, -8, 4.2, 8, 0, 9. Okay, second quit. Now we're going to do second matrix. I'm going to say matrix A minus, oops, second matrix, matrix B. So just like we have on the paper there, matrix A minus matrix B. Bam, hit enter, and the magic happens. We get 6, 2.52, -5, 14, 1.8, -10, 7, -0.6, just like I have there. My goodness, aren't these calculators great? Okay, and let's say you have this fancy schmancy calculator up to the TI-30X Pro, the chromed out edition. This one can do matrices as well. The regular one cannot. So this is the regular blue calculator. This is the chromed out edition of that one, which can do matrices, which means you would do the same here. Second matrix. And how many does it let us do? It just lets us do 3, which is perfect. You go over to edit, and it's just like the graphing calculator. So I won't show it all. You go edit, you'll do 3 rows, 3 columns, then you'll type in the numbers, and you'll do the same thing that I did on the graphing calculator. Exact same process. Okay, there you go. That's how we make your life easy. All right, so let me get back to mine. Okay. So there's me, there's me, there's me, there's me, more me, bam. Okay, cool. Let's keep going. All right, so this one says that you can multiply a matrix by some number, by some constant, k. So, for example, 3, you have 3 times this whole matrix. So what you're going to do is multiply every element inside that matrix by 3. And you see it becomes -6, 3, 0, 15, -3, 12, 2, -4, 5. That's it. All you do is multiply the matrix, every element in the matrix by the number on the outside. So we're going to try it here. So all we're going to do here is multiply every element by 6. So 6 times 0.5 is 3. 6 times 1 is 6. 6 times 4 is 24. 6 times -7, -42. 3, 18. -5.5. What's that? -33. 6 times 1.25. Oh, what's that? 7.25? I hope so. 6 times 1.25, 7.5. 0 and 12. There it is. That's it. Nothing to it. All right. Now we get into multiplying matrices. All right. So we can confuse you with all this nonsense, or I can just make it really simple. In order to multiply your matrices, they don't have to be the same dimensions, but the number of columns in matrix A must be the same number of rows in matrix B. So what I'm saying is that this p-value must be equal to this p-value. If those p-values are equal, then the resulting matrix is going to be an m times n matrix, which is over here on the right side. So the resulting matrix will be m times n. All right, so that's how we multiply matrices. We say if A is m times p, and B is p times n, if this p and that p are equal, then the result is that matrix A times B is a m times n. That's it. Don't have to confuse you with any of the above. All right, so those values of p must match up. That's it. And if they don't, well, you can't multiply. You move on. All right. So we want to just practice working with the dimensions of the matrices and seeing if we're actually able to multiply them. So this says that if A is a 4 by 3 matrix and B is a 3 by 2 matrix, then what are the sizes of A times B and B times A? Okay, first up is A times B. All right, so looking at matrix A, right? Oops. This is matrix A. It has 4 rows and 3 columns. Now looking at matrix B, it has 3 rows and 2 columns. 3 rows, 2 columns. Are these values equivalent? Does 3 equal 3? Yes, right? These two values are equivalent, which means the resulting matrix will be a 4 by 2, right? The resulting matrix will be a 4 by 2. Okay. Now, all it wants us to do is fill in the elements. Let's see. There we go. Okay, so 4 by 2, 4 rows by 2 columns. So 1, 2, 3, 4. 1, 2, 3, 4. 4 rows by 2 columns. That's it. All right. Try it again. All right. So now this is matrix B and this is matrix A. B is still 3 rows by 2 columns. A is still 4 rows by 3 columns. Is 2 equal to 4? Not at all. Those are not equal, which means we cannot multiply these matrices, which means that makes them undefined. It's as simple as that. Check your dimensions, and if you can't, you can't. We move on. All right. You try as if a class is here listening to me. Oh, all right. So if A is 5 by 7 and B is 2 by 5, what are the sizes of A times B and B times A? Okay. So this means that first, for A times B, or better yet, there we go, you would have a 5 by 7 times a 2 by 5. Now, does this 7 equal that 2? Not at all. So A times B is undefined. Okay, what about B times A? B times A means 2 by 5 times a 5 by 7. Are these two values equal? Yes. Oops, equal. Those 5s are equal, which means the resulting matrix will be a 2 by 7. There you go. That's it. Okay. All right. Now we're going to get into some crazy stuff. We're actually going to be multiplying these matrices. All right, so the product of a row matrix and a column matrix, each of the same size, means to multiply the corresponding elements and add. All right, so product of a row matrix and a column matrix, the product of a 1 by, excuse me. The product of a 1 by n row matrix and an n by 1 column matrix is a 1 by 1 matrix given by, well, here you go. So the first matrix over here, what we're saying is that this is a 1 by n matrix, right? A 1 by n matrix. The second matrix given is going to be a n by 1 matrix. Okay, the reason we put n is because we have no idea how many columns the first matrix has. It goes on forever. And for the second matrix, we have no idea how many rows that matrix has. But what we know is that these n's are equal, and the result is a 1 by 1 matrix. Is a 1 by n matrix. So the way we do this multiplication is we say element A1 times element B1, which is here, plus element A2 times element B2. All the way till you go through all your elements until you get to the final element, which is element A sub n times B sub n, which ends your final result. And once you add them all up, this would create a 1 by 1 matrix. Okay, let's try it out. Or first, let's look at the example. Okay, so example 5, the first matrix is 1 row by 4 columns. I'll write that down below. This matrix is 1 row by 4 columns. The second matrix is 4 rows by 1 column. This means that this 4 is equal to that 4, which means the resulting matrix will be a 1 by 1. 1 row, 1 column. Okay, and showing how they do the matrix multiplication again. First element in matrix 1 times the first element in matrix 2. There it is, 7 times 3. Plus second element in matrix 1 times second element in matrix 2, right there. And then again, 0 times 8 plus 1 times negative 9, bam. Multiply them, add them, you get 2. Okay, that's it. Which means let's practice on ours down below. All right. First thing we want is dimensions. So our first matrix is 1 row by 3 columns. Our second matrix is 3 rows by 1 column. Those are equal, which means the resulting matrix will be a 1 by 1 matrix. So let's start on the math. Oops. All right, here we go. 5 times 4. So 5 times 4 plus 3 times 1. Plus -2 times 0. Multiply them. You get 20 plus 3 plus 0, which leaves us with 23, which is our 1 by 1. There you go. So that's how we do that. Can you do this on your calculator? Yes, you can. But let's get to a bigger one, right? This one's too easy. We don't need to use a calculator for that. Let's get to the more massive matrix multiplications. Which is down below. Whew. All right. So look at this example. A 3 by 2 multiplied by a 2 by 3. This 2 is equal to that 2. Which means the result is a 3 by 3. All right. Now, check out all this work. My goodness. All right. So the way this works is when you multiply these, you're going to do, to get the, what is it? Oh yeah, we'll just say to get the first row of our 3 by 3, first thing you're going to do is you're going to say -1 times -1, which is right here, plus 1 times 1, right there. That makes the first entry in our new matrix. Okay. And then the next thing we do is -1 times 0, which is right here, plus 1 times 2. That is the second element in row 1 of our new matrix. And then we do -1 times -1 times 3, which is right there, plus 1 times 2, which is right there. That makes the third element in row 1 on our matrix. Starting to see a pattern? Let's do it again. All right, so we've exhausted the first row in the first matrix. Now we're going to do the second row. So this would be 2 times -1, which is right there. 3 times 1, which is right there. Then, again, 2 times 0, right there. 3 times 2, right there. And then, again, 2 times 3, here. 3 times 2, there. Okay, so what we're basically saying is that the rows in the first matrix are multiplying the columns in the second matrix. Once you've exhausted the rows in the first matrix, then you move on. Well, once you've exhausted one row, you move on to the second, and you move on to the last, however many rows there are, right? And again, there is a pattern here, right? So again, we do show you the very last one. Now we're going to do row 3 times column 1, column 2, column 3. That's all that's going on here. So 1 times -1, right there. 0 times 1, right there. And then, again, 1 times 0, right there. 0 times 2, right there. And then 1 times 3, right there. 0 times 2, right there. Whew. And that's how you piece them together. It's row times columns, row, second row times columns, third row times columns, and then you'll get there. Okay. So you might be seeing a pattern, because if you look at this, well, here's -1, here's 1, -1 and 1, right? -1 and 1 from the first matrix, and then here's -1 and 1, -1 and 1 from the second matrix. Well, look at this, -1, 1, -1, 1, and everything else is the numbers from the rows in matrix 1. So there is a pattern here, which can make it a lot faster to multiply. So once you multiply and add everything up, you get the final result of this 3x3 matrix. Whew. Okay. Now, let's try it on our own, but we're gonna use a calculator because I don't need this video going on forever. Lucky you, right? All right. So first thing we look at are the dimensions. This is a 3x2 times a 2x4. So 3x2 times a 2x4. These are equal, which means the resulting matrix will be a 3x4. All right. So let's go back to my other screens. Bam. Here we go. All right. Now let's make our lives easy. Second matrix, go to edit. And now my matrix is a 3x2. So 3 rows by 2 columns. And I have -1, 1, 2, 3, 1, 0. Second, quit, second matrix. Edit matrix B, which is a 2. Oh, by 4. This one does not let you do by 4. So if you have this calculator, you're doing it by hand. Oh boy. Sorry, kids. Okay, which means let's go back to this one. Second matrix. Edit. This was a 3x2. All right. So negative. Whoops, where did I go? Stop. Too many buttons. All right, 3x2. -1, 1, 2, 3, 1, 0. -1, 1, 2, 3, 1, 0. Second, quit, second matrix. Edit the next one. This is a 2x4. 2x4. And you get -1, 0, 3, -2, 1, 2, 2, 0. Okay, second quit. And we want to multiply matrix A. So I'm going to say matrix A times second matrix B. And the magic is going to happen. Bam. There it is. Life is good. So we get 2, 1, negative 1, 2, 6, 0, negative 1, 12, 3, 2, negative 4, negative 2. There it is. Done. All right. Perfect. Okay, what's next? Oh, almost done. Okay, find each of the following if the operation is not possible, write undefined. Okay, so first up is matrix C plus matrix E. Matrix C plus matrix E. Well, I'll write the dimensions above up here. So matrix C is a 3 by 3. Matrix E is a 3 by 3, which means we can definitely add them together. All right, put myself in the middle. It'll be weird. Okay, so that means we can add those. You can plug those in your calculator if you want. If not, I'm just going to look at it from here. So this means that my matrix will also be a 3 by 3. And I'll look at the first one. That's 4 plus negative 1, so that's 3. 0 plus 8 is 8. 8 plus 2, 10. Okay, do it again. Negative 2 plus 0, negative 2. 6 plus negative 7, negative 1. Negative 5 plus 15, 10. Okay. Last one. 0 plus 2, 2. 2 plus 3, 5. 13 plus 9, 22. There it is. That one's done. Okay. Now B says 4 times E minus C. Well, all this wants us to do was multiply matrix E by 4 and then subtract it from C. So there's still going to be 3 by 3s. So again, I'll just make our work easier. Let's see. So I'll say second matrix, edit, it's now 3 by 3. And I'll do it's negative 1, 8, 2, 0, negative 7. Oops. Negative 1, 8, 2, 0, negative 7, 15, 2, 3, 9. 2, 3, 9. All right. Second quit, second matrix, edit the next one, which is also a 3 by 3, which it's 4, 0, 8, negative 2, 6, negative 5, 0, 2, 13. All right, second quit, and I'm going to say 4 times matrix E, which is my matrix A, minus matrix C, which is my matrix B. and done. Because that would be -4 minus 4, so -8. Yep, that's it. So -8, 32, 0, 2, -34, 65, 8, 10, 23. All right, perfect. Okay, next is B times A. So A is a 2-row by 3-column matrix, and B is a 2-row by 2-column. Okay, so the first thing we want to check is dimensions. So matrix B we said was 2 by 2. Matrix A is a 2 by 3. Which means these are equal. Which means the end result is a 2 by 3. Okay. So let's do it. All right, so we're going to do B times A. So I'll just go back and edit my matrices. Matrix, edit. So matrix A, which is going to be my A now, is a 2 by 3. And it is 2, 7, -4, 3, 0, oops, 3, 0, 6. Second, quit, second matrix. Edit B, which is my actual B now, 2 by 2. 3, 9, -1, 5. 3, 9, -1, 5. Second, quit. Whoops. Okay. Let me make sure that matrix is right. And I can check. 3, 9, -1, 5. Okay, excellent. Okay, so we want to do B times A. So I'll say second matrix B times second matrix A. Done. There it is. Feels kind of bad, but if I was doing all of these by hand, this video would be long. So, and it's also nice to show the students how to use their calculators. 33, 21, 42. 13, -7, 34. Oh, and yes. Yeah, I mean, I'm definitely torn. I'd rather do these by hand, but again, I don't need this video to be super long. So it's all right. I'll sacrifice one time. Okay. All right. Excellent. Now we want D, which is B times D. So D's dimensions are 3 rows by 2 columns. Okay. Which means for B times D, matrix B we saw was a 2 by 2. Matrix D is a 3 by 2. These are not equal, which means we cannot multiply matrix B times D, which means that this operation will be undefined. All right, not bad. Okay. And then the next is C times E. All right. Matrix C is a 3 by 3. And matrix E is also a 3 by 3. These two are equal, which means the end result is again another 3 by 3. All right, which means let's get to calculating. All right, so just to go along with it, I'll make them my matrix C and E. So I'll go down to matrix C, 3 by 3, and 4, 0, 8, -2, 6, -5, 0, 2, 13. Second quit, second matrix. And I'm gonna make this E, which is also 3 by 3, which is -1, 8, 2, 0, -7, 15, -1, 8, 2, 0, -7, 15, 2, 3, 9. Okay, we're ready to go. So I say second matrix C times second matrix E. Boom, done. Life is great right now. All right, 12, 56, 80, -8, -73, 41, 26, 25, 147. And there it is. Perfect. Okay, awesome. All right, so let's actually apply these matrices to an application. Yay, right? Other than just doing a bunch of math, right? All right. One moment. Okay. 7. A personal computer retail company sells 5 different computer models through 3 stores. The inventory of each model on hand in each store is summarized in matrix M. So inventory is in matrix M. Wholesale and retail values of each model computer are summarized in matrix N. So the wholesale and retail values of these models. Okay, so what is the retail value of the inventory at store 2? So what is the inventory, retail value of the inventory at store 2? So what that means is that we need to take the row for store 2 and multiply it by the retail column in matrix N. So let's try that down below. So this is going to be A. So our matrix M that we've taken out, right? Our matrix M is 2, 3, 5, 0, 6. And the piece of matrix N that we've taken out is, oops, $840, $1,800, $2,400, $3,300, and $4,900. Okay, well, let's look at our dimensions. And matrix M is 1 row by 1, 2, 3, 4, 5 columns. So this is a 1 by 5. Matrix N is 1, 2, 3, 4, 5, 5 rows by 1 column. Okay, this 5 and this 5 are equal, which means that the resulting matrix will be a 1 by 1. All right, and we can do this by hand. This is the easy one. Okay. So here's what we're gonna get. You're gonna have 2 times 840. Two times 840, right? And then plus 3 times 1,800. 3 times 1,800. Keep everything in parentheses. All right. And then plus 5 times 2,400. Plus 0 times 3,300. Plus 6 times 4,900. Close matrix. Now add all those up. Multiply them and add all those up. I got 2 times 840 plus 3 times 1,800 plus 5 times 2,400 plus 0 times 3,300 plus 6 times 4,900. And we get 48,480. Which means the retail value at store 2 is $48,480. There you go. Okay, that's for A. B, what is the wholesale value of the inventory at store 3? Okay. So this means we take store 3's row and multiply it by the wholesale row. Okay, so just like we did in A, we're going to do this in B. B. Okay, so we first have the first row, which is 10, 4, 3, 10, 4, 3, 4, 3, multiplied, so this is still matrix M, and then multiplied by matrix N, the wholesale column, 700, 1400, 1800, 2700, and 3500. This is matrix N. Okay, and these should be no different than the ones above them. It's another 1 by 5 times 5 by 1. So again, we would get a 1 by 1 matrix. Okay, which means we can just move on to the actual multiplication. And let's begin. You'll get 10 times 700 plus 4 times 1400 plus 3 times 1800 plus 4 times 2700 plus 3 times 3500. Multiply them, add them up. 10 times 700 plus 4 times 1400 plus 3 times 1800 plus 4 times 2700 plus 3 times 3500. We get 39 300, which means the wholesale at store 3 is $39,300. That's the wholesale. Okay. Last question. Determine and interpret the product M times N. Okay. So determine and interpret what the product of M times N is. Can we even do it? Let's see. So to start with, matrix M is 3 rows and 1, 2, 3, 4, 5 columns. 3 rows, 5 columns. Matrix N is 1, 2, 3, 4, 5, yeah. 5 rows, 2 columns. Okay, so this means that for C, you would have 3 by 5, which is M, 5 by 2, which is N. These 5s are equal, which means the resulting matrix would be a 3 by 2. Okay, well, let's multiply those and interpret what we get out of it. Okay, so we'll get a 3 by 2. All right, so I'm going to go second matrix, edit. The first one is a 3 by 5. And you would have 4, 2, 3, 7, 1, 2, 3, 5, 0, 6, 10, 4, 3, 4, 3. All right, second quit. Back to matrix, edit this one. My next one's a 5 by 2. All right, 700, 840, 1400, 18, 18, 24, 27, 33, 35, and 49. Okay, then we'll do M times N. So that was second matrix A, my 3 by 5, times second matrix B, my 5 by 2, enter, and we get that M times N gives me 33,400, 42,160, 35,600, 48,480, 39,300, and 5,700. Okay. So it says interpret. Well, what matrix M times N does, so if matrix M is the inventory and matrix M is the wholesale and retail values at each store, then matrix M times N, the columns give you the wholesale value at each store and the retail value at each store. So that's what matrix M times N is the wholesale and retail values at each store. Is the wholesale values, which is column 1. Retail values, column 2, at each store. Okay, that's it. Okay, there you go. Those are matrices. Yeehaw. And you see how your calculator makes them a lot easier to work with. Okay, of course, having the right calculator. If you don't, it'll build character, but you got to do them by hand. Okay, that is it, guys. Where is my record? Stop recording.